Hello, today we will be taking through our project MOSAIC, a way to piece together our future on Mars. Before jumping into what MOSAIC is, I wanted to share why do we care about Martian exploration. So, why Mars? Mars has captured our imagination for centuries. It's the most Earth-like planet on our solar system, with evidence of past life hidden all throughout. The availability of resources like water ice makes it a promising candidate for exploration and even colonization. But it's not without its challenges. The thin atmosphere offers little protection from high levels of radiation, and the surface is a dusty, desert-like environment. Oxygen is scarce, and temperatures swing from freezing to unbearably cold. Overcoming these hurdles will be critical to building our future human habitats on the red planet. The journey to Mars is as thrilling as it is demanding. Let's explore how MOSAIC can rise to this challenge. Our mission is clear. MOSAIC pioneers Martian research and occupation, advancing humanity's presence in space. Through cutting-edge technology and innovative exploration, we're laying the groundwork for sustainable living on the red planet. MOSAIC's opus will create a highly detailed map of the surface composition, elevation, radiation, and visual spectra, which will then be used to choose two potential occupation locations. The tiles will then land at those locations and collect meteorological and atmospheric data over time so future Martian colonies understand the environment and can establish outposts effectively. We have three goals for mission success, guided by this year's AIAA undergraduate competition. First off is mapping at least 75% of the Martian surface. Secondly is to gain a greater scientific understanding of the conditions on Mars. And third, inspire human occupation of Mars and future generations' drive to keep exploring our universe. So I've used the word mosaic over and over again, but what is it? It's the Mars Orbital Survey and Imaging Cartographer, which encompasses our orbiter along with two probes. Our orbiter, OPUS, stands for Orbiter for Planetary Understanding and Sensing, and it not only gathers data to make a map of Mars, but will also hold and release two tiles over two potential landing sites. In order to carry out our mission, OPUS will carry four science instruments. The laser altimeter and high-resolution imaging camera will be used to characterize the Martian surface, obtaining detailed topographical maps and collecting data about surface roughness, brightness, and slope. The gamma ray and neutron spectrometer and the composite infrared spectrometer light will investigate the elemental composition of the Martian atmosphere and surface, respectively. Our probes for this mission are TILES, which stands for Terrestrial Investigation of Landscape Erosion and Space Weather, and the two TILES will collect our meteorological data over the years at their Martian site. Each TILES probe will carry two science instruments. The first of these is the radiation and dust sensor, which will estimate the optical properties of dust, such as abundance, coverage, and composition, as Mars's seasons change, as well as cloud cover. The second instrument, the radiation assessment detector, will measure radiation levels resulting from the sun and cosmic rays, as well as from the Martian planet itself. Part of the novelty of our project is specifically looking at dust and radiation because both of these factors will be incredibly important considerations when sending humans and equipment to Mars. We want colonization locations to have minimal issues related to instrument and hardware failure due to the high abundance of radiation or dust accumulation. Here is our concept of operations, and we will go through it quickly. We first start with launch from KSC on December 31st, 2028. After entering Mars' sphere of influence, the orbiter will then go into aerobraking maneuver for about 5.5 months, and then go into a science orbit, which is about 250 kilometers above surface. Once the science orbit is reached, our orbit data collection begins, followed by determination of the landing locations as outlined by mission control. Tiles are then deployed to surface, and surface science data collection begins, while the orbiter continues its science orbit around Mars. At end of life, all systems are powered down and they stay in their current locations. Here's an overall look at our trajectory and orbital plan. After our launch to Leo, we go into our transfer orbit to Mars, followed by a 163-day aerobraking campaign. We then recircularize and enter our mapping phase, where one map takes 119 days to image. From there, we will create more maps to capture topographical changes and add more detail to our initial mapping. With our inclination angle, we plan to cover close to 80% of the surface. Notable budgets of our project include a total cost budget of about $993 million, which does fall under our $1 billion cap, and this price does include inflation. We also have included a mass budget where you can see the majority of our mass is propellant and Opus related. However, our mass very comfortably fits within the limitations of our launch vehicle, the Falcon Heavy. Thank you for taking the time to get to know MOSAIC, and we hope to inspire you to also help piece together our future on Mars.